So there is a next illustration, that is your illustration number 1.8. Illustration number 1.8. So in this illustration, it is to be related to the calculate the acceleration of electron and proton, calculate the acceleration of the electron and proton, and calculate the time taken by the electron and proton to travel this much distances. Okay. Now the question of this one, it is like this: an electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2 into 10⁴ Newton per coulomb. The direction of this field is reverse, keeping its magnitude unchanged, and a proton falls through the same distance. Compute the time of fall in each case. Contrast the situation with that the free fall gravity. Okay, compare that value with the free fall gravity. Okay. So the first of all, distance between the two plates 1.5 centimeter, convert into meter, multiply 10⁻²⁰ meter. Magnitude of the electric field 2 into 10⁴ Newton per coulomb. Into first diagram, lower plate is positively charged, upper plate is negatively charged. Into second diagram, the polarity of the plates are reversed. Into first diagram, electric field is upward direction. Into second one, it is in a downward direction. In the first one, we place the electron. Into second one, we place the word proton. Okay. Now the figure A, electric field is in a upward direction. Electron experiences a force in a downward direction. That force acting on it, that is F is equal to EE. Equation number 1. From the Newton's second law, F is equal to ma. Compare these two forces so that we can say that ma is equal to E. Now make a subject of A. Therefore, A is equal to E by m. Once we calculate the acceleration of the electron, select mass of electron. When we calculate the acceleration of proton, select mass of proton. Only this small changes takes place. Okay? Where E is equal to, we know very well, 1.6 into 10⁻⁹. E is equal to 2 into 10⁴. Mass of electron 9.11 10⁻31. By calculating them, your answer will be coming 3.5 into 10⁻15 meter per second square. This is the answer of acceleration of electron. Okay. Now student, calculate the time taken by the electron to travel this much distance. Let me say 1.5 centimeter. This electron performing a accelerated motion from the rest, so that using the equation of motion, electron starting from the rest, therefore initial velocity u is equal to 0. Equation of motion d is equal to ut plus half at square. U 0, this term is cancelled, therefore half at square remain. Now please make a subject of t. It is a t square, under root of 2d by a. By making a subject of t, it is under root of 2d by a, where a replaced by what? Acceleration of the electron. Where student 2 is it is distance d 1.5 to 10⁻² meter. Acceleration of the electron is 3.5 into 10⁻15, just calculated. By calculating this answer will be coming 2.9 into 10⁻9 second. It is a time taken by the electron to travel this much distance of 1.5 centimeter. Okay. So now this equation and this equation, it is remains as it is, no change, no change. Same calculation, it is for the proton. Now what happened? In figure B, direction of the electric field is reverse. Similarly, calculate acceleration of proton, that is F is equal to E by mass of proton. Charge on electron 1.6 10⁻19. Electric field E 2 into 10⁻4. Mass of proton 1.67 into 10⁻27. Therefore, by calculating them, acceleration of proton is 1.91 into 10⁻12 meter per second square. Okay. Now, time taken by the proton. Again, this same equation can be used. What changes takes place? Acceleration of the electron replaced by acceleration of proton. Again, same equation, under root of 2d by ap. Distance d 1.5 10⁻². Acceleration of the proton is 1.91 into 10⁻12. By calculating them, your answer will be coming 1.25 into 10⁻7 second. This is time taken by the proton and this is time taken by the electron. So now observe the acceleration of the electron and proton. Acceleration of the electron, it is in the order of 10⁻15. Acceleration of proton is, it is in the order of 10⁻12. Compare this acceleration with the acceleration due to gravity. So that acceleration due to gravity, that is 10 meter per second square. We know very well acceleration of the electron and proton is much larger than that of gravitational acceleration g. Therefore, effect of the gravity it is neglected in this example. Effect of the gravity is neglected in this example. Okay. Now student, we are moving on the next illustration. That is your illustration number 1.9. And now this example it is related to the electric field. It is related to electric field. Before starting this example, student, remember it. Due to positive charge, electric field is radially outward. Due to negative charge, electric field is radially inwards. Remember this direction of the electric field, please. Now we can solve the illustration number 9. The question is like this. The question of the illustration number 9, it is to be given by 2-point charges Q1 and Q2 of magnitude plus 10 raised to minus 8 coulomb and minus 10 raised to minus 8 coulomb respectively. Are placed 0.1 meter apart. They are placed 0.1 meter apart. Calculate the electric field at point A, B and C as shown in figure. Calculate the electric field at point A, B and C as shown in figure. So this is a Q1 plus charge 10 raised to plus 8 coulomb. Second charge 10 raised to minus 10 raised to minus 8 coulomb. Like this is plus charge, this is minus charge. Separated by 0.1 meter apart. 0.1. Half of the 0.1 is 0.05. Again half of the point is 0.05. Like total distance between these two 0.1 meter. See, this is point A, this is point B, this is point C. Calculate the electric field at point A, B and C. So first of all we will calculate the electric field at point A. So due to this plus charge outwards, due to this minus charge again it is inverse direction. Due to plus outwards like this, due to minus inverse like this, both are in direction, same direction. Therefore electric field at point A it is E1A due to plus charge Q1 charge. Due to minus Q charge it is E2A. They are in the same direction, therefore addition is takes place. Once again student, at point A due to this positive outwards like this, due to this negative inverse, both are in the same direction, therefore addition is takes place. Electric field at point A, Q1 and Q2 10 raised to minus 8 coulomb, R1 R2 both the same distances 0.05 meter. Therefore E1A E2A is equal to, so due to point charge electric field K Q1 upon R1 square plus K Q2 upon R2 square. K Q1 upon R1 square plus K Q2 upon it is R2 square. Okay. So value of K 9 into 10 raised to 9. Q1 10 raised to minus 8. R1 0.05 whole square. Again same value of K. Q2 is 10 raised to minus 8 and R2 is 0.05. Both terms are the same term. Therefore answer will be coming 7.2 into 10 raised to 4 Newton per coulomb. It is acting towards the right side. Therefore towards the right hand side it should be given. Now the point A electric field is completed. Student, the electric field at point B, due to this Q1 charge, it is towards left because it is plus charge. Electric field at point B due to this minus charge, it is towards the right hand side. Okay, that is should be write down on this board. Electric field at point B due to Q1 charge towards left, due to Q2 charge towards the right. This is towards left, this is towards right. Therefore, between these two electric field, subtraction takes place. Subtraction takes place. Okay, so that the resultant electric field at point B is equal to, it is a E1B minus E2B. E1B minus E2B. Into the previous case, there is a plus, but into the next case right now it is a minus sign. Into the previous case, the electric field both are in which direction? Same direction. Therefore, we place the sign plus sign. Okay. Now, student, this is called the R1 distance. This much R1 distance is what 0.05, and this total distance, it is called the R2 distance. 0.05 plus 0.05 plus 0.05. It is 0.15. So that R1 is 0.05, R2 is 0.15. Now the electric field due to point charge K Q1 by R1 square minus K Q2 by R2 square. Value of K 9 into 10 raised to 9. Q1 is 10 raised to minus 8. R1 is 0.05 whole square. Value of the K again 9 into 10 raised to 9. This is Q2 10 raised to minus 8. R2 is 0.15 square. This much calculation, their answer is 36,000 and this answer it is equal to 4,000. Now subtract them 32,000. So that answer is 3.2 to 10 raised to 4 Newton per coulomb. This is the electric field at point B. See, this answer is more. E1B answer is more than that of the E2B answer. So that the resulting electric field it is acting towards the which side? Left side. It is towards the which side? Left side. Now calculate the electric field at point C. At point C, electric field due to positive charge outwards, due to negative charge inwards. E1 and E2 they form the parallelogram. So the resultant electric field it is produced in a diagonal direction. So that electric field F1C can be calculated by using the law of parallelogram. R1 and R2 distance is the same distance, therefore the electric field is also same. Therefore F1C electric field is from the law of parallelogram. R1 R2 is equal to 0.1 meter, therefore the electric field E1 E2 also same answer E. Now from the law of parallelogram, that is EC is equal to under root of E1 square plus E2 square plus 2E1 into cos 120. So we know very well cos 120 always minus 1 by 2. E1 E2 replaced by E, therefore E square plus E square plus E into E led to E square minus 1 by 2. 2 cancel, plus E square minus E square cancel, only E square remain, out of square root it is E. Now electric field due to point charge kq by r, kq by r square. What is value of k? 9 into 10 is to 9. What is value of charge q? 10 is to minus 8, and distance r is what? 0.1 square. By calculating them, your answer is 9 into 10 is to 3 Newton per coulomb, and this electric field acting towards the right side. Okay, now the example is completed.